This research paper estimates the carbon footprint of the astronomy community due to global travel to scientific meetings in 2019. The study highlights the significance of quantifying greenhouse gas (GHG) emissions in academia, particularly in the field of astronomy, which has a strong dependence on international travel. The authors compiled a dataset of 362 conferences and schools that took place in 2019, computing a total of 42,500 TCO2e emissions for travel to these meetings. This equals an average of 1.0 plus or minus 0.6 TCO2e per participant per meeting. The total travel distance for these meetings amounts to roughly 1.5 astronomical units, equivalent to 1.5 times the distance between the Earth and the Sun. The authors present scenarios for reducing these emissions, such as virtual conferencing or hub models, while prioritizing the benefits of conferences for the scientific community. The paper emphasizes the imperative to drastically reduce GHG emissions to mitigate the climate crisis. Aviation contributes 7% to global human-made climate forcing, with 23% of this directly from CO2 warming. The authors discuss the correlation between the visibility of a scientist and their amount of air travel, highlighting the need for researchers to critically assess their own travel behavior. The study provides a benchmark for comparison with other fields and serves as a basis for future reduction strategies and assessments. The findings can be mapped onto other scientific fields with similar structures regarding conferences and schools, making this study relevant to the broader scientific community. The authors emphasize the importance of changing conference habits to improve equity and inclusivity in the field of astronomy. Here is a combined summary of pages 3 and 4 of the research paper. The authors investigate the carbon footprint of astronomy meetings in 2019, analyzing 300 meetings with complete datasets. They categorize these meetings into conferences and schools, with conferences being larger events aimed at the entire astronomical community and schools being smaller events focused on students and early career scientists. The authors estimate the travel-related carbon footprint for each meeting, combining the data to assess the climate impact of astronomy's pre-pandemic meeting habits. They find that the total amount of greenhouse gas, GHG, emissions is approximately 38,040 TCO2e, equivalent to traveling around the Earth 5,650 times or 1.5 astronomical units. The mean travel emissions per participant for conferences and schools vary depending on the geographic location of the meeting. Conferences have a mean emission of 1.1 plus or minus 0.6 TCO2e per participant, while schools have a lower carbon footprint of 0.7 plus or minus 0.4 TCO2e per participant. The highest mean emissions per participant are attributed to meetings in Africa and Oceania, while European meetings tend to have a slightly lower carbon footprint due to shorter travel distances. The authors also analyze the localness of participants, defining a local participant as one who travels as less than or equal to 200 kilometers to the meeting location. They find that meetings with a higher fraction of locals have significantly lower mean emissions per participant, but the distribution of carbon footprint per participant scatters significantly between 0% and 35% of local participants. The study highlights that minimizing total distance traveled is a good approach to reducing conference emissions. Meeting sizes vary significantly, with a majority of conferences having between 128 and 861 participants, while schools have significantly fewer participants. The authors find that the mean travel emission per participant is independent of meeting size. Finally, the authors visualize the locations of meetings and participant travel origins, finding that nearly half of all meetings take place in Europe, followed by North America and Asia. The distribution of meeting participation by home institution is similar, with European-based astronomers being the largest group. Here is the combined summary of pages 5 and 6 of the research paper. The analysis of 300 astronomy and astrophysics meetings in 2019 reveals a significant carbon footprint, with an estimated 42,559 plus or minus 353 TCO2e emissions attributed to travel. The geographical distribution of meeting venues and participant origins indicates that Europe and North America dominate both distributions. The majority of participants originate from institutes in Europe, 42.1%, North America, 31.2%, and Asia, 18.3%. The remaining 10% is distributed among Oceania, Central and South America, and Africa. The participant numbers versus Colorado 2E emission per participant illustrate that a fifth of all meeting attendees originate from institutes in Asia, while the remaining 10% is distributed among other continents. The fraction of IAU members at Asian institutions is higher than that seen participating in meetings. The compiled meeting list may lack local events organized for these communities, which could explain the disparity. The location of home institutions of conference and school participants is illustrated in Figure 6, with the size of circles scaled by the number of trips taken from each location. The color coding indicates the emissions per conference travel averaged over all trips from that location. The most trips are taken from locations in Europe and the east coast of the USA, with researchers in Europe benefiting from shorter distances and lower Colorado 2E emissions. To estimate missing emissions from 62 meetings without participant information, the average emissions per participant and continent were derived from other meetings. This resulted in an additional 4,519 plus or minus 353 TCO2e, with 4,154 plus or minus 349 TCO2e from conferences and 365 plus or minus 50 TCO2e from schools. The discussion highlights the need to reduce travel-related carbon footprint in scientific meetings. Options for in-person meetings include optimizing meeting locations, considering hybrid or fully online meetings, and re-evaluating the career prestige of organizing or participating in meetings. Meeting organizers could utilize a priori knowledge of participant origins to reduce emissions significantly. For example, hosting a conference in mainland Europe or northeastern USA instead of Palm Cove, Queensland, could have reduced Colorado 2E emissions by more than half. Here is a combined summary of pages 7 and 8 of the research paper. The astronomy community's climate emissions are significantly contributed by global travel to scientific meetings. To mitigate this, alternative meeting concepts such as hubs, hybrid meetings, and online-only meetings can be explored. Hubs, where participants travel to the nearest of several locations connected virtually, can bring significant reductions in emissions. For example, a two-hub model for the 233rd AAS meeting in Seattle, Washington, could reduce emissions by 60%. Hybrid meetings, which involve an in-person component and a virtual attendance component, can also bring further carbon reductions. A hybrid model for the same AAS meeting could reduce emissions by 17%. The adoption of these alternative meeting formats can also address issues of equity and access. In-person meetings can create barriers to participation for many, particularly those from minority groups, due to factors such as funding, time, and visa requirements. Virtual events can be just as successful as in-person ones, and can provide greater accessibility and inclusivity. The cost of travel and accommodation can range from €500 to over €3,000 for a 5-day meeting, making it difficult for researchers from less wealthy and less renowned institutes to participate. The distribution of funding for work-related travel varies significantly by country, institution, and even within institutes, with senior researchers traveling more than early career researchers. Researchers in more advantaged countries have a lower cost of travel and are more likely to attend in-person meetings. The Human Development Index, HDI, of a country is correlated with conference attendance, with countries with higher HDI having more attendees and producing more GHG emissions through travel. Moreover, 81 countries were missing from the 2019 conference attendee population, highlighting the exclusion of many countries from in-person conference participation. Overall, the adoption of alternative meeting formats and a focus on equity and access can help reduce the carbon footprint of astronomy and make scientific meetings more inclusive and accessible to all researchers. The COVID-19 pandemic has forced the research community to shift from in-person meetings to virtual ones, providing an opportunity to reassess the environmental impact of these events. This study focuses on astronomy meetings in 2019, highlighting the significant greenhouse gas emissions, GHG, associated with travel to these events. The analysis reveals that the total GHG emissions for travel to open astronomy and astrophysics meetings in 2019 was 42,500 TCO2e. The average carbon footprint for travel to a conference is estimated at 1.1 plus or minus 0.6 tCO2e per attendee, with a lower average of 0.7 plus or minus 0.4 tCO2e per person for travel to a school. The study also emphasizes the importance of making the field of astronomy more sustainable, accessible, and inclusive, considering factors such as the struggle to balance work and family responsibilities, the exclusion of certain groups due to in-person meetings, and the potential benefits of virtual meetings for fostering collaboration and networking. The paper proposes a path forward to more sustainable and inclusive meetings, including reducing the number of meetings, adopting a hybrid format that prioritizes the needs of online participants, and utilizing technology to host virtual events. The authors also stress the need for universities and research institutions to incentivize the shift towards more sustainable practices regarding long-distance travel, and suggest that senior researchers should take the lead in this transition. This research paper estimates the carbon footprint of astronomy conferences and meetings in 2019. The authors calculated the CO2 equivalent emissions from travel to 362 meetings, accounting for flights, trains, and car journeys. They assumed a threshold of 300 kilometers for train travel, with longer distances traveled by plane. For meetings held on islands, participants were assumed to fly if they originated from further than the approximate size of the island. The authors found that the choice of train traveled distance influences the calculations, with an average variation of 1.7% and a maximum difference of 20% in 3 out of 71 alternative calculations. The carbon intensity of train trips was assumed to be 23 gCO2 ekm1 per person, while flights were modeled using a selection of different emission models. The authors used the calculator from the Travel Carbon Footprint Calculator, which considers direct emissions from aircraft fuel burning and upstream emissions for fuel production. The radiative-forcing index, RFI, for the combined 3 models used was 1.92.0, equivalent to approximately 165 gCO2e per passenger per kilometer for long-distance flights. The authors noted that other factors, such as average passenger load and travel class, have an influence on the carbon footprint of each journey, especially for air travel. They assumed that all flights were done in economy class and with 100% occupancy, which likely underestimates the emissions. The authors also discussed the limitations of their study, including the lack of complete data on astronomy meetings, incomplete participant lists, and the simplification of direct routes between travel origin and destination. The paper presents a robust baseline for future comparisons of conference travel emissions and highlights the need for more accurate and detailed data on travel routes and modes. The authors acknowledge that their estimates are likely conservative and dependent on the choice of RFI value and direct flight assumptions. They provide their calculated data files and a demonstration of the data analysis on GitHub, along with supplementary material online. This study explores the carbon footprint of astronomy research, focusing on the impact of international travel to scientific meetings in 2019. The findings suggest that these events contribute significantly to the field's overall carbon emissions, with a total estimated emission of 4,000 tons of CO2 equivalent. The analysis highlights the need for sustainable practices in scientific collaboration and knowledge dissemination, particularly in the context of global climate change. The paper discusses various strategies to reduce emissions, such as virtual meetings, hybrid events, and offsetting flights. It also emphasizes the importance of considering the environmental impact of research activities, including travel for conferences, workshops, and seminars. The study draws on a comprehensive dataset of astronomy events and participant travel data to estimate emissions, providing a baseline for future assessments and improvements. Moreover, the research touches upon the role of international collaboration in science, emphasizing its importance while acknowledging the environmental costs associated with it. The authors propose a shift towards more sustainable forms of collaboration, leveraging digital technologies to minimize travel-related emissions. This shift could not only benefit the environment but also increase accessibility and equity in participation, especially for researchers from developing countries or those with limited resources. In conclusion, the paper calls for a critical examination of the environmental footprint of scientific research, particularly in the astronomy community, and encourages the adoption of sustainable practices to mitigate climate change. The proposed strategies aim to balance the need for face-to-face interactions with the urgent need to reduce carbon emissions, ensuring that the pursuit of knowledge does not compromise the planet's health.